I jumped from the research side over to the production side. Should point out I never worked for the mobile phone division. I worked for the majority part of the company, which did networks. I was actually taken on because our privacy group at Nokia Services had a problem. Nobody was listening to them. And so they thought it might be a good idea to take on somebody who actually had some software experience. I mean, they were trying to tell people how to write software. So having somebody with software experience might be a good idea. So I joined that. Um, let's just say it was an interesting experience. In my first couple of weeks there, I was given a document, 150 pages long, written in Word, in legalese, by some lawyer who said, I do not understand why nobody understands or is using this. So that was pretty much it. I had a very, very interesting battle for about up until 2014, trying to get people to get away from this idea of compliance. Everyone thought I was absolutely crazy, and along comes the GDPR, which reads more like a risk management document than anything to do with compliance. Turns out there are some very, very good reasons for that, and I can actually trace certain passages in the GDPR to some of the work that I did on risk analysis and safety critical systems. Anyway, the problem we had huge before I get to the slides, which is kind of what actually came out of this, we had these huge processes for auditing software and so on, and all the products we were doing, and it was completely unmanageable. So I actually started off on a project to try and educate people how to model systems in such a way that we could go and analyze what was happening. Turned out we had lots and lots of failures along the way, a little bit of serendipity. So I brought in a lot of ideas from safety critical systems, aviation, etc., on how to analyze systems and how to come up with checklists on what should be there, what shouldn't, how you analyze risk. Lots and lots of failures in that. It wasn't until about 2011, 2012 that I suddenly realized, with a little bit of serendipity, that aviation was a really, really bad example for doing this. And we actually started using examples from medicine. So there is a book by a guy called Atul Gawande called The Checklist Manifesto. It talks about how they developed the surgical safety checklist, which is exactly the model that we used for privacy. So anyway, after all this, I was kind of a controversial person within the company. I decided to write all these things down, write it down as a book, actually put all this stuff into practice. And then after having too much of lawyers telling me that everything should be compliant, I decided to jump from privacy and become a real cybersecurity person, back into research again. However, I still talk about this stuff now and again because, well, people demand it of me. So anyway, so I was a really, really bad privacy engineer, so they kicked me out. So what did we learn? This is where it gets really, really, I think it gets interesting. Let me just share this. I hope this works. I'll share that. And hopefully you can see this. So it says the fundamentals of privacy engineering. Everyone nod and wave. Good. Okay, so as I was telling Isabel earlier, I have about 1,000 different slides on this subject, and I stick them together in various forms for lectures. So this is basically a lecture I've given many, many times, just to educate people on what I think privacy engineering is, and this is what I learned from my engineering background. Pretty much all the material in here you'll find in the book. I'm still waiting for the film rights of it, but in the meantime, I will. Well, let's just say if you write a book, you're not going to become rich. So let's see if I can make. Please say this. Great. Okay, so you should. So actually, I started off because there were a lot of people telling me that what privacy was. And none of it made actually any sense whatsoever. So the first thing I started doing was actually looking at all the different ways people talk about privacy. And I mean, whenever you talk about privacy, it's always brought up as a legal construct. It's always, here's the GDPR, it's set in law, etc. It's legal, everything. It turns out, I mean, this is an incredibly old concept. It dates back to 1890, which is the first modern use of the term. Where does the legal construct come from? Society, business, law, etc. And that gives us the concept of privacy. But there are more interesting ways of looking at privacy. It's a philosophical construct based out of ethics, morals, etc. I guess if you know Helen Nissenbaum, the philosopher at I think it's University of New York, she was one of the leading figures in privacy, or probably still is. If you go actually read her material, she actually talks about data flow analysis quite deeply, even though that she's not she doesn't know she is, and so on. Right. I mean, you can also think of it as an economic construct. In fact, people talk about how much will privacy cost us, brand value, and so on. Then there's this thing, privacy by design. I hate this. I must actually say that right now. I think this was probably, it's a lovely idea, um, but it got taken up by a lot of people who really do think that if you do privacy by design, and this is all there is to it, everything is solved. And nobody ever talks about what you need to do in order to satisfy the 7 very, very good ideas inside here. Well, I'm going to pick out one because privacy is a game theory construct. We talk about privacy being a positive sum game. It should benefit everybody. Well, yeah, absolutely, until you start looking into what positive sum games are. And there is a very good paper and a Nobel Prize from George Akerlof on called The Market for Lemons, where he actually examined the used car market in the United States in the 70s and 80s. And basically, yeah, the car dealer was making a profit. You were getting a car, so it's a positive sum game. You drove that thing for about 100 meters and then the car broke down and there was no legal repercussion. Um, so when people talk about positive sum games, you need to have some balance between the the two participants. It cannot be so overwhelmingly one-sided. I'll give you an example. How much of Facebook's profits have you seen actually come back to you from all their advertising revenue? If the answer is billions, then okay, great, privacy is working for you. If the answer is you've never seen anything come back from Facebook apart from hey, a few likes now and again, then you really are losing in this. Even though what you get back from Facebook is probably it's nice and positive and happy, but you're not really getting it's not balanced between you and what Facebook have. So positive sum games great, but just make sure there's some balance there. And then privacy as systems engineering. I mean, I'm an engineer scientist as my training. I'm actually a mathematician at some point. And then I have to deal with legal people. And so to any lawyers on the line now, I will insult you mercilessly throughout this presentation. I apologize for it deeply. But basically, we do not speak the same language at all. Um, I don't expect lawyers to understand how we build systems, and I don't expect our systems engineers to understand subtleties in law, but I do expect them to communicate. And that was our first major problem that we had to solve. Quite simply, how do we go from something like privacy by design, which everybody can understand, to an actual piece of code? And what I learned quite often was everyone just started talking about, well, just make it compliant, as if compliant was this magic thing that just happened. One of the reasons I actually left privacy was because after modeling sort of what was going on in our systems at quite a detailed level, doing all the data analysis, etc. I mean, it was a complete mess. But as long as we had that privacy notice there when the user first logs onto the system, it was all fine somehow, as if putting up a privacy policy solved everything. Whereas in reality, everything underneath was a complete mess. The data was being shared in all sorts of different ways. From an engineering perspective, it was just cobbled together because we had to, things had to be done. So we often get trapped in this compliance mode, and in the end, when we talk about privacy, all it really means is that we're slapping a privacy we're slapping a privacy policy onto the front of our UIs and hoping for all the best after that. Compliance is fragile. We when we talk about privacy compliance, you can see in this cartoon, there is your privacy policy, and it says quite clearly. I mean, they're only collecting was it temperature or something else from these two teams. I mean, we have complete, what you end up here is complete information asymmetry, that the people writing the privacy compliance notice actually know all the loopholes, etc., whereas the people actually having to uh, accept this do not really understand what's going on. Here's another example. I mean, this is my favorite. So we once had a product, I won't tell you too many details of it, which actually had a telemetry module. It collected data in exactly the same way as your phones do now. They report everything back to Google and Android, and we were all quite happy with that, apparently. But we had a module in some of our phones that could send data back to Nokia. For privacy reasons, I mean, this took months and months. I think probably a couple of man-years over the course of 6 months to actually figure out how we should do this. And in the end, it came down to, well, all we need to do is, it's a simple engineering thing. We just have a button on there. You say, yes, you want the data collected or no. And this was sent out to the cheapest contractor who then implemented it. I normally do this as an exercise. Basically, I think it was in the region of 4 or 5 man-years of lawyer work in order to get this module passed. And the code on the right-hand side is the code that was actually written for this, somewhat attenuated, of course. It actually turned out that it does, if you go and read that code, it actually turns out that there's a very, very small bug in that code. It's actually 6 ASCII characters. Because those 6 ASCII characters were missing, it absolutely blew everything that was done for those 4, 5, 6 man-years out. Turned out in the end, actually, our devices were sending everything back, regardless of whether you wanted it anonymized or not. And then a few months after that, we actually discovered that the wrong module had been sent to the OEM, and so it was actually just sending back test data and nonsense. So, but the point is here that it doesn't matter how much effort you put into all the legal side, etc. The coding side, you can ruin all that just by a simple mistake. In this case, there is a piece of code that says case N, don't do anything. If you know the C family of languages, then you'll also understand that if the way these languages work, if there's nothing there, then it'll follow through right through to the next case and just carry on. So regardless of what you check, it'll keep on collecting data. The point here is that 6 ASCII characters will just destroy your life. So how do we address the privacy engineering problem? Quite simply, I was told that engineers need to understand privacy lawyers. My take on this is actually maybe the lawyers need to learn how to speak to the engineers, but this was kind of controversial. So actually started to try and figure out how we go and address this. And the first thing that everyone comes up with is, let's come up with a privacy process. Great, another process, that's all I need in a, I've already got too many processes. It does not matter how agile your software engineering is, another process will just grind things to a halt. It's another set of loopholes to go through. And in fact, our processes would go to the software engineers and ask, are you privacy compliant? And the first thing they would answer is yes, because if they said anything else, the lawyers would get involved in the process, and that's the end of the software. Where I came from was to actually look at what skills and techniques we needed to be teaching both sides in order so they could develop the software, analyze the privacy constraints and aspects around this. So we start off with looking at how we deal with requirements, what kind of language do we use, how do we model these systems, metrics, and then the very, very interesting one at the end was how does our culture need to change? So the first thing we did was requirements. And we started off at looking at exactly what our systems were doing and at what kind of levels do we want to think about these systems. I mean, there's a huge difference between a privacy policy and the requirements that we need, say, in our architecture, design, or coding. There is a link between them all, but it's very, very tenuous. So just because you have a privacy policy does not mean that this is easily or even possible to translate this into any requirements for a piece of software or any kind of system. So the details were, or the abstraction level of the details were a problem from the start. But then we started looking at what people were actually talking about. They were talking about things like, What's our privacy policy for handling location data? What's our privacy policy for handling identities, and so on? And then we came up with a whole bunch of aspects such as, okay, how do we store locations? How do we store identities? What's our policy for this? What's our architectural constraints? And we started building up a database of requirements with these three tags. So if somebody asked, what's our policy on the storage of location data? And then we'd be able to trace that down to, okay, what are the architectural requirements that derive from that? What are the design requirements? And we also had a set of rules to say, okay, if there's something missing, then how do we go back up? If we do not have, say, a requirement for the retention of location data when we architect the system, can we move this up? Do we have a policy for that? Do we have a more generic version that we can then start refining and build from there? So that's how we derived the requirements framework. So we started looking at what kind of elements we had, what kind of aspects do these get applied to, and what level of detail do we want. And once we got some of this down, it then became very, very much easier for example, the lawyers to actually understand that they were dealing at a policy level, and then there had to be a huge amount of work to get this or translate this into even a form that the software architects could use. And then it was a lot easier after that because these people tend to come from the same background. The next thing that we hit was what does information mean? There's a lot of talk about, okay, we're not allowed to store location data or what identities are. And what actually struck me was I have a background in information theory and semantic web and so on, is that basically everything that you thought information was is wrong. So I'll give an example. And we had huge conversations this year. What's an IP address? And I think the common sense answer, well, it's the address of your computer, and we shouldn't collect them because you might discover where somebody is. Unfortunately, that's not how IP addresses technically work. I mean, there's routing and all other mechanisms inside Share. We had some very interesting conversations coming from this. So, for example, when a web server generates its logs, it obviously gets the IP address of the caller. We did have one requirement come up from our privacy lawyers who basically said that we are no longer allowed to use IP addresses, which is a kind of a fundamental problem in how the entirety of the internet works. I mean, it's like going to the post office and saying for privacy reasons you're not allowed to write addresses on envelopes anymore. So there were some huge misunderstandings of how these things work, how the technology underneath works, and so on, how things, what actually has to be there. So we get down to, okay, what does an IP address mean? And it turns out there are actually many, many interpretations. And what you actually see here are some of these graphs of which as you've all bought the book already, you'll recognize these graphs from the book, I'm hoping. You'll actually start seeing things such as, okay, what does an IP address actually mean? In some contexts, it really does identify a computer. In other contexts, it identifies the building. The IP address of the machine on my desk is one thing. There's the address on the router. There's also the address that I'm accessing this video conference through. That address is actually the address of a server of a VPN provider. So we have different aspects to this. The other thing is the IP address could actually be, for certain periods of time, your actual identifier for some devices. It is the identifier of a device. It might even be the identifier of a person for certain periods of time. Another example, locations. Locations are great. I actually saw some people, lawyers going, are you collecting GPS coordinates? And the engineers are saying, well, of course we are. We're building mapping systems. And first thing is, well, stop collecting them, which makes, for example, so Nokia used to own Navtec, which then became a company called Here, which was the mapping company. It makes things such as navigation applications rather difficult to build if you tell people they're not allowed to process location data. An interesting example that came up once is the curious case of 38 North, 97 West, which is a point inside the continental United States. You notice there's a small farm nearby. So I'll ask you a question. Unfortunately, I can't see everyone, so I'll answer it for you. Is this a location? And it turns out, well, yes, it's a location in Kansas, but 38 North 97 West is rather special. It turns out that this was used as a null value in a database. There was a company in New York who actually keep the geographic coordinates of data centers. And if they didn't know where a certain IP address was of a data center, then they'd assign it the geographic center of the United States as the null value. What this meant was people who were receiving spam, if it was, say, coming from Amazon servers or Google servers, they would use this company to get the location of those servers. Then they would actually drive out to the center of the continental United States, find this farmhouse, and go and attack the people inside. The point of this was that just because it looks like a location doesn't mean it is a location. The other classic example is your email address as a login ID. And I'm going to leave that as an exercise to the reader. Just because it contains an @ symbol, and probably a name with a full stop, and a domain name with a full stop and a top level domain at the end of it, does not mean it is an email address. We had some very interesting situations regarding this. Before email addresses became common as user identifiers for you log in, you'd have a username. Now, if the user cancelled their account, we would, in some systems, you would actually go and recycle usernames. The problem is that for legal reasons, you'd actually have to maintain the link between the username and the email address for a long period of time, which meant that it was possible that in some cases that email address would then get mixed up with other usernames. Anyway, that's an interesting exercise. When does okay, there's a typo on this slide, which has been there since 2016 or earlier, and nobody's noticed. When do things become personal data? Because we had this huge discussion over what is personal data, and my argument here is that you can never say when anything is personal data. I mean, at the end of the day, it's just a series of bits and bytes existing inside a computer memory. It's all the interpretations you give on top. And in fact, for something to become personal data, you need an analysis of the data underneath. And then once you've done that analysis, then you can make the decision of whether that is or is not personal data. And then you need to look at the context in which you're using it. We can get it, I've seen some very, very interesting situations. So for example, we had a help desk system that obviously had to keep logs of questions and interactions between the help desk people and the users. One of the requirements was that we were not allowed to keep any of those logs because they were personal data. Yet that was the fundamental point of how the system worked. So if you get stuck on this, is this personal data? Then you're actually missing the point. You need to do a much, much finer grained analysis of the data underneath. And then you need to start looking at the context, which is where the data flow modeling comes in. What we started to do was one of the successes I had was to ban the term personal data within Nokia, which no mean feat. I managed to ban personally identifiable information as well. What we tried to do was to prevent the lawyers talking about personal data and prevent the engineers talking about what was actually held in the databases. So the engineers were saying, well, we've got this big SQL database, here's the schema, with the question, well, is that personal data? And neither side could agree on this. So we started looking at, could we come up with a set of intermediate concepts which would allow both sides to communicate? So the things that we came up with were things like characteristics. These are things like names, addresses, dates of birth, things that identify people and places and so on. There was financial data. Content data was the more opaque things like, say, pictures or sound files and so on. And a lot of things that ended up in the content classification could be broken down into other things. So, for example, a picture, like a JPEG, actually might contain a lot of personal characteristics. It would contain location information, identity information, and so on. Health data, because we needed to make the distinction between medical data and, say, exercise data. Identifiers and the various kinds of identifiers, machine identifiers, personal identifiers, social security numbers, temporary identifiers, session identifiers. You can't just, in order to properly understand what identity is, you need to break down into what identifiers are. So while, for example, I mean, we had some interesting cases where people saying, well, if we just go and hash the email address, does this make it anonymous? As well, it makes it anonymous, but all you've done is turn one identifier into another kind of identifier. Now, I don't know the original email address before, but I can still do all the processing over that. I mean, as far as a computer is called, an email address and a hash are identical things. And if they have a one-to-one mapping, then you haven't introduced any privacy at all. Maybe a bit of bad cryptography, but no privacy. So identifiers are a very, very complex subject. Temporal data, specifically referring to times and durations and timestamps, and then location data and the various kinds of location data. So we started off with that. And then, later on, I think I might have some examples of how this breaks down. There's certainly in the book anyway. So it allowed us to talk at a very different level. So instead of asking, are you storing personal data? You could ask, are you storing identifiers of some form? And then what kind of identifiers and what's the longevity of these identifiers? And do we need to process those identifiers and so on? We did the same things with other concepts. So there was a lot to talk about the privacy risks that we were taking. If I asked you, are you taking any privacy risks? The answer is, well, if you're a lawyer, it's yes. And if you're a software engineer, you say no immediately. But there are different kinds of risks. There are the risks of monitoring, surveillance, the collection of data, the aggregation of data. We have to collect data in our systems for log files. But once you start collecting data, then you have the risk of aggregating data. What kinds of identification can you perform on that? Were there any other kinds of insecurity, disclosure, and confidentiality? So instead of talking about risks, we would then compartmentalize those risks and say, okay, you have log files. What are you doing to mitigate the risk of collection of data? What are you doing to mitigate the risk of aggregation of data, and so on? Usage. First thing I learned in privacy was it's actually all about the usage of data, and this was incredibly interesting because there was no distinction between the data we collect in order to provide the service and the data that we collect in order to provide the system. Meaning that if you build REST interfaces or whatever, you are going to collect IP addresses and you're going to go and collect browser strings and all the data that gets sent by the browser and the IP protocols underneath. There's nothing you can do about that. You have to collect that data and you have to use that data in order to provide the system that's providing the service on top. Now, where it gets interesting is when the data between these two levels starts getting mixed up. So what happens if you ask the question, can I use the IP address that's collected just because that's the way the internet uses? Could I do geolocation of that and use that in order to improve the service offering I have? And so on. So there were a lot of cases along there. One interesting that we all often saw were people talking about, well, we're collecting this data for some future usage, which was, a big alarm bell. And then there's all the requirement aspects that go on this. So you can see how, for example, some of this now relates back to the requirements we talked about earlier. There are lots of different requirements aspects, how we collect data, how we store it, and the way we store it might depend upon the device or where it's located in the world or whether it's cloud-based. How we transport the data, handle it, and all sorts of aspects like this. So this actually set us up with at least some kind of language and some meaning for these terms that allowed both sides to start communicating with each other. I guess, it took us a few years to get this far. And I should actually point out that these are highly customizable. So I did some of these, or I modified them for the oil industry in Finland. Or an oil producer in Finland, I should say, or an energy provider. Oil is so ungreen these days, and they actually worried about a completely different. While the requirement aspects and the usages were the same, they had a very, very different risk and information model, but the principle remains. So basically, what we started doing then was, okay, once we have data, then we would classify all that data between the type, the usage, the purpose, the provenance, and the identity. Often it was just enough to use type and usage. So even though we have ontologies for a lot of things, you don't have to use them all. So it was enough to say, okay, in this data set contains temporal data, identity data, and location data, and it's being used for marketing purposes. And that was enough to start off a fairly sophisticated privacy analysis of that. What we would then do is go and map that then to our requirements. Once we had those requirements, we could map those to which risks were we dealing with, and then eventually we could calculate some kind of risk metric to say, okay, is this system very sensitive, or is this system too risky for our business model, and so on. There's a feedback loop here, of course. So I'm going to sort of jump through these fairly quickly because there's another about 200 slides to go. We also did an exercise of trying to come up with another metric for the sensitivity of information. So in these broad categories of information, you see certain things come up often. So for example, in location data, you see country, city, address, IP or cell ID, latitude or longitude, and you can order these in terms of sensitivity or risk or identifiability. So we came up with a model here just to allow people to get some idea of how much risk they were taking. So if you have a data set that, for example, contained, I don't know, the social security number, ethnicity, gender, and location of people with a fine granularity of time, that's obviously an extremely risky set of data to be holding. If you just have, say, country and year against some kind of identifier or a short-term identifier, then maybe this is this is a less risky piece data set to be working with. So the point here was to come up with a very coarse metric for understanding how much risk we were taking with a particular data set. I notice I've still got the old terms PII on this, so we were able to draw a line through this and say, okay, the things on the left-hand side, this probably isn't going to be personal data or personally identifiable information. The things on the right are. As soon as you have something on the right-hand side, then you need to start worrying. If everything is on the left-hand side, then you're probably fine. But combinations of these, I mean, if you have location and identifier, then obviously the combination of these together actually means you could push this very easily into the personal data section. So, but the point here was to give people an idea of what kind of risks they were taking. So I'll give a short example now. I guess we all have applications on our phone that share and store the data in the cloud, and I guess we've all shared pictures of things and so on. So let's call this the social camera app. This was an example that we used with our lawyers for training them in this. Pretty much every application you see has a privacy policy, which you accept or decline. Invariably, you accept it because you don't read it, and if you did read it, you wouldn't understand it anyway. Then you get to a screen which probably has things like, do you agree to our marketing policy? Do you agree to vast amounts of spam? And PS, we want to take all the telemetry off your device as well. You always say, you accept that because that's what we all want. And then you get to use the app finally. And this is the way we looked at systems. And it was not sufficient. Because what was actually happening underneath was data was flowing everywhere. So we started using data flow modeling. We have a small language for this. And the model you see here, this was actually based on one product that we had at the time. We gave this model to our lawyers, and they were kind of they just did not understand that this is where all the data was flowing. So there was no concept of, there was the app and it's a big black box after that. It goes out into the cloud, which is a magical place somewhere. So we spent a lot of time actually describing what information was flowing to various places. Just because things get shared to social media providers doesn't mean it's a privacy risk. There are things that, there are mitigations you can take. You can strip the metadata from pictures before you send it to Facebook. Facebook themselves actually strip the metadata from pictures, but they also store it as well and use it for other purposes. Just because things go out to a cloud backend doesn't mean this is a privacy risk and so on. So we also augment these models with ways of dividing up logically. So we can say, okay, these are the bits under our control. These are the bits that are not in our control. In this case, the device and the service provider are in our control. The top three boxes are outside of our control, in which case the data flows crossing these boundaries would be points at which we would have to put in mitigations, do further analysis. So it gave us the justification for doing these things. The model I have in front of you now, so we did a lot of work with these models, and they're incredibly useful. The software engineers hated them, the lawyers loved them. Software engineers hated them because they were so simple, and the lawyers loved them because, well, lawyers are simple. Sorry. It was the first time they actually saw what was going on. And then I was actually asked, okay, what's really going on in the systems? How far can you take this? And I came up with this model to show all the data flows in one very, very simple camera application. So we took a lot of things into consideration: where location was coming from, where the visual environment, the picture, the user, what happens when you share to a social media provider, where all the routes you can go. It actually became quite interesting because it turned out that our backend systems, the box on the right-hand side, were quite convoluted inside. We also noticed that there were some interesting loops, that it was possible for our business analytics team to get data from the advertisers. You know, the advertisers are generating their data from our products and so on. And we actually figured out there were some very interesting ways of, even though all this was supposedly anonymized, by combining the data that we were getting from the advertisers with the data that we were getting from our systems, we were able to start to correlate these together and actually de-anonymize people. And it became quite interesting that a lot of this data was actually being fed through to our marketing department, who were then feeding that back to the users. So we had a number of points where data was actually getting mixed up. And when we got down to this level of model, then we started getting some very, very deep questions about what we were really doing with the data and where it really was flowing. I think this particular model caused a few sleepless nights for a lot of people. Certainly, there are other ways of modeling. I'm going to skip the next couple of slides because there are various different ways of modeling this, which are better explained elsewhere. One interesting one was when we started tagging these data models. So we talked about the usage of data. Now, if you're writing a privacy policy, you try to get in as many usages as possible. We had one interesting incident where when NevTech became Sure, we had to rewrite a new privacy policy. It was rewritten afresh, and it actually turned out that inside that privacy policy, we had actually forgotten about location data, which is kind of interesting for a mapping and navigation company, but there you are. What we noticed with these models, because there is a logical flow from the data subject out to some endpoints, if you looked at each of the endpoints and attached a usage to those endpoints, are we using the user account database for? What we're using the analytic reports for, and so on. As you work back against the data flow, the usages basically add up. So what we get at the end of the day is a set of usages that can be applied to that data subject. So any data coming from that data subject will be used for the total sum of all usages at the endpoints in the model. Now, this gets a little bit more interesting when you start making the cross-referencing this exact with what kind of information. So just having the type of information and the usage, so we could say, well, your user ID will be used for user account management. Your IP address will be used for system provisioning. The geolocation of your IP address, which is a location, will be used for providing the service, and so on. Once you add all these up together, we actually figured out it actually became rather trivial to compute what our privacy policies should actually look like, and we could actually specifically tailor that to the model. But before we actually got to that far, what we had here was a formal system for actually deciding what was being captured and what things were being used for at any point in the system. And then from that, we could go back to the requirements and map that to that model and so on. So everything started building up together. And then eventually we came up with a model of exactly what kind of information we needed to gather, what should be modeled, what should be gathered by the lawyer, or what the lawyer should ask for, what the engineer should provide, and how they then should analyze this. So basically, engineering comes down to modeling. You need to be able to understand the system, the method by which you get the models. It should also be pointed out that even though you have a lot of techniques available to you, you don't have to use them all. In fact, some of the most interesting analysis we've ever done are on the most simple data flow models you can imagine. Ontology, meaning what do all these things mean? How do they all link together? And how you perform the analysis of these. So that's what the engineering process is. I want to get on quickly onto metrics and then start off with the statement that there are no good or usable metrics for privacy. I'd like to say this is a lie. We did a lot of papers with the machine learning community on metrics for privacy. You can go and read them. They're wonderful papers, but it took 3 people with PhDs to even just get the basis of the theory out. We sent these to some privacy conferences. They all got rejected because we dared ask the question, how do you measure anonymity? And apparently anonymity is a trivial concept and we shouldn't even be asking this question. On the other hand, the machine learning community love this stuff because they need to be able to measure these things in order to be able to make inference about systems. There are some frameworks for this. NIST has one. It basically says you should measure privacy and not much more than that. Turns out that if we come back to this model, we actually have we already have the properties of a metric. Now, a metric is a mathematical concept anyway, but we have the basics of a measurement system. It's not a very good measurement system. I would say it's on the level of, shall we say, medieval weights and measures, where things can vary depending on context or where you are, or the phase of the moon and so on. But the point was that we did have a way of measuring system, and what we could do is say, okay, if you have these categories of information and you are taking these risks, then we can say, okay, this system is too risky, this system is not. This is how we mitigate it, and then we actually had a way of saying, look, if we put these requirements into place, are we mitigating our risks? Now, what normally happens with a system is that you try and come up with a set of requirements that fulfill all your privacy needs. What normally turns out is that these requirements are so constraining, you could never build a system with this. I mean, if you try to literally interpret the GDPR, you would never build a system that would satisfy that. So what you try and do is retrench on your requirements. You start removing requirements from the system to allow you to process things, and that takes you to an area which we call the zone of acceptable risk. Now, it depends upon the company. If you're Facebook, then you're quite happy taking huge amounts of risk with people's data. If you're a company like Nokia, we were very, very conservative and basically worked with German and Finnish privacy law to say, this is how much we're going to do. So your process, which I brought back earlier, I mean, the feedback loop, which I briefly mentioned, actually came down to one of how do we remove privacy requirements from a model. So you'd actually start off with saying, okay, here's all our requirements. This means we don't take any risk, but we also don't produce the product, which is the ultimate non-risk taking. And then you start removing the requirements, weakening things in the system until you actually find a system that is workable. Now, there is some really, really interesting and sound mathematics behind this. And if you give me another 20 years and funding, I'll be able to work them out for you. But a lot of the theory behind this is already well known in software engineering. The final thing I want to talk about is, I'm using time up, is the culture, because that was the most interesting thing. In the end, we spent a huge amount of time trying to get privacy lawyers and privacy engineers, or just engineers, talking to each other. I think we were quite successful on this. But what we noticed was that we had to stop making things black and white. We had to move to a much more risk-based approach. Now, this is exactly the same way as the aviation industry or the medical industry actually works. I shouldn't say the medical industry, should I? They actually work on a principle that there is going to be risk, but you do everything you can to mitigate this. And there's a huge amount of techniques for this. You can't see, but I have a bookshelf on how you manage risk in aviation. It's a kind of hobby of mine. Um, Aviation has crashes, we have privacy breaches. If you look at the way the aviation industry deals with a crash, it is completely different to the way we deal with a privacy breach. There are lots of reasons for this. One, there's a tangible value, there's a tangible physical asset, there are human lives. In privacy, we just don't care. When it was actually medicine had the data breach a number of years ago of some very sensitive information, um, while there was a value placed on this, don't, I think the company is still running under a different name, so obviously nobody cared too much. There were at least attributed to this 3 suicides. So there is there is a human cost to privacy breaches, but we've never actually managed to metricize that. The How we ended up down this route, I did a lot of work of trying to get a lot of aviation development principles and management and risk principles into how we developed our systems. And all of these failed in horrible ways. That's another story, which I can go through another time. But basically, it was a little piece of serendipity that I actually discovered that there was work done in the late 90s in medicine on how to introduce aviation-like procedures into the medical environment, specifically the operating theatre, surgical environments. And what struck me was the way doctors practice medicine is very, very similar to the way software engineers practice engineering, in that we operate in a very, very volatile, very agile environment. And the way we started thinking about this is we actually drew a link between infectious substance handling in medicine and the way, and if we treated data in the same way, what happens if you consider data to be dangerous? Um, Biggest shock here is, hey, did you know we can learn things from other industries? And this actually comes as a shock to some people. Obviously, nobody here, but it is a shock. Um, so like I said, we actually examined a lot of industries. Aviation is my pet hobby. Actually, the work I'm doing now is in the rail industry, of all things. There's some very interesting cases here. As an exercise, it's very interesting to read accident reports, because they do not try to pin blame. They try to figure out the cause and how it happened, and go back through all the processes that led to that. The bottom left picture was actually the aircraft crash. I think it was sometime in the 1940s that actually started off modern risk analysis in aviation, and that's another story. What we started to do was look at checklists. These are not tick box lists, so there's a particular way of using these. And this is the checklist that should have been followed in the Air France A330 crash about 5, 6 years ago, but wasn't. These are known to work, but there is a particular technique for using them. Uh, where we drove, what we discovered was that this idea was actually used in Johns Hopkins University in the UK by a guy called Peter Provnost, who started looking at infection rates in patients for certain procedures, came up with a checklist, and then from that started looking at all the other things that came from this. And the main thing here was that he couldn't change the process, but what he could do was change the tools that we use. And so they changed the way they literally packaged the tools for performing this particular procedure. They also changed the power structure so that while this procedure is being performed, anybody present could call stop. And it didn't matter whether they were student nurse or whether they were the leading consultant in the country. They were all given the power to say stop. You can see the two statistics in the top right here, basically saying that this technique worked. So we actually drew a lot of inspiration from this and used actually we used the same model used in surgery called sterile field. So we considered data to be something dangerous, and it had to be sanitized and controlled how it flows. In fact, all the techniques for data flow analysis, classification of data can be used in this field as well. And actually, we did this as an exercise. There was an exercise late 90s to come up with the surgical safety checklist. It's done by the World Health Organization. What you see on the screen now is the checklists that we developed based on that exact structure for performing privacy audits. And once we started doing this, it actually gave us a way of saying, okay, this is what I have to do at this stage. These are the things I need to check. The interesting thing about this was that if we could not get some information, so if somebody couldn't tell us what the purpose of the system was, or they couldn't tell us all the data that they were going to be gathering, we would say it doesn't matter. We would move on to the next stage. We would allow them to continue. We would never ever stop a system from being developed, which was completely novel. But what it did meant was if we did not have certain information, then both we and the project engineers knew exactly what was going to be asked, what they needed to do for the next stage. Okay, ultimately, at the end of the day, there was a yes, no, or a stop go decision made on whether this thing goes public or not. But at least at this point, everyone knew what was expected from them at each stage, what they needed to do. And if something was missing, it didn't matter. So there was no pressure on the engineers to come up with some arbitrary documents that say, yes, we've covered everything. So we would always allow things to go. We would never say no to something as long as people were doing their best in order to achieve or try and at least answer the questions that we were asking of them. What actually happened in the end was we developed a number of other checklists from this as the engineering teams became, shall we say, much more proficient in answering our questions. We could devolve even more responsibility to these guys. And in the end, as we devolved more responsibility to them, we could actually sit back and they would come to us and saying, hey, we're going to make the monumental privacy disaster here in a minute. Help us get out of this. So we turned everything around from, shall we say, this war between the lawyers and the engineers into something that was very, very much more proactive. We had that communication so the engineers could come back to the lawyers and say, hey, look, we're doing this. Help us make it better. What do we need to do in order to get this through? And then the lawyers then could actually translate into language that the engineers would be much more comfortable using. There's a very nice quote from Atul Gawande in his book, the Privacy Engineers Manifesto. The point here is basically medicine's complexity has exceeded our individual capabilities as doctors. You can apply that to engineers, privacy lawyers, whatever. Basically, the reality is the systems we're building are far more complex than any privacy lawyer, engineer, software engineer, anybody can actually understand, and we actually do need to work together on this. So I'm going to come to a quick summary of this. Okay, I've gone really, really rapidly through the fundamentals and all the semantics and ontology that we built up, how we model systems, and ultimately how we ended up with some notion of how the culture should change. And that's basically what we did, and it worked. It was incredibly hard work. I wouldn't say we were 100% successful, but we were. I mean, when you're starting from nothing, any success is infinitely better than no success. So I think at the point where I basically left to go back into cybersecurity research, we had enough set up that it was very, very easy for people to do their own analysis of systems and to communicate properly. So I'll stop there and take questions. Whew.
We didn't have so far any questions in the chat.
Yes. This is Keith. Can you guys hear me?
Yes.
Yes, it's also fine if you speak up. It's also fine like that. Go
Okay.
ahead.
Great presentation. I was very, very controversial as far as not using pi, that term pi anymore. I think it would the reasons why were incredible. Where is there a way that, is there somewhere available where we can get that ontological breakdown of how you did that? I thought that that was really incredible. And
Yeah.
the other part of my question was risk frameworks. What did you use to communicate risk to your legal and business partners? Is it something, did you use one of the standardized frameworks like FAIR or RMF or anything like that? And or did you do something on your own?
Okay, I'll take the second part first. We actually developed our own. In fact, I wouldn't say we developed, we just basically said, we came up with a small ontology of risks and said, okay, these, let's try and get back to that. It's quite a few slides back. I think it's back here somewhere. No, it's going forward. So all we really did here was we didn't want to burden anybody with any more frameworks, procedures, and so on. So, well, all we did, as you can see on the slide here, is just look at what people were calling risks, and then came up with a classification of these and said, okay, here are all the risks that we as privacy people worry about. We did one of these for security as well, or there are different aspects of security, and said, okay, there are some links between here. So if the security guys do this, then you can map it to this and vice versa. But all we did was come up with a language for talking about risks and nothing more. And the reason we didn't do anything more was basically not to burden anybody. Already we had so much pushback on people worrying that we were going to come in with yet another process and yet another way of doing things, and here's some more documentation to describe the documentation. We wanted to remove all that and go into projects and say, just ask, what are you doing? And then we could go in with some very, very specific terms. So what data are you collecting? So we wouldn't even talk about risk. We would just ask people, what data are you collecting? And then they would tell us and say, and are you aggregating this over periods of time? And then they would say, oh, no, we don't do any of that. So immediately they were actually doing the risk analysis for us. They were telling us all the information we needed to know in order for us to come up with some kind of risk analysis. Now, at the time we did this, NIST was still coming up with their risk analysis and their risk models, which weren't ready. And to be honest, they're not mature enough. I don't think there is anything outside of safety critical engineering that is mature enough, or should we say agile enough to use in the environments that we had. So to answer your question, no, we never came up with our own model or our own framework. We basically came up with terminology and let the framework kind of develop organically out of that, and let just see what happens. What were people comfortable using, and so on. So that was the main thing there. I guess the people who really needed a risk model at the end of the day were the lawyers, but they already had some ideas about what that meant to them anyway. And what we wanted to do was actually facilitate the communication. Your first question, which was where can you find all this? I wrote a book on this, which Isabel will hold up in a moment. And
Yeah, it is.
so sorry to do the plug. I recommend you buy the Dead Tree version and not the ebook version, because ebooks do not handle formatting in any sensible way. That's my answer. There are some papers around. There's an awful lot of presentations that I've given on this. So on SlideShare, and I'll send these links to Isabel a bit later. So on SlideShare, there's about 30, 40 presentations about this. I have some papers on the subject. I'm more than happy to share those. They're all public anyway. So there's all that, and then there's the book that basically where everything was put together. Now I will say the book was written before or it was published 2014, so it was before the GDPR, and everyone was talking about the GDPR at the time. I beat you all to the risk management stuff on that. But everything inside there is kind of relevant anyway. So nothing has really changed. I mean, so even though it's pre-GDPR, it doesn't matter. The biggest things that come out of there are the things that I would use are basically the types of information, the types of usage, the types of risk, the requirements aspects and the checklists. Once you've got those, the data flow modeling actually to use a pun, flows quite naturally from that. Once you've got those, it's up to you how deeply you use them. I did not want to put any constraints on what had to be used, what shouldn't be used. It might, in some cases, you actually find that a trivial data flow model and just writing down 3 or 4 circles with lines is enough. In other cases, you have to do a much more detailed analysis. I didn't want to come up with any process around that, but all that is, the book is the Bible on that, if you like.
Okay, thank you.
You're welcome.
I would like to remind that we are recording this session, and in principle only the presentation and the one speaking it's being recorded, but just mind yourself if in case you want to speak with the camera or not, so you know it.
So we have a question in the chat. Is there a way to quantify risk? And the second question is how to remove subjectivity from this risk calculation.
Ooh, good question. Yes, and you're not going to like the answer because, for example, in aviation, it's quite simply a monetary value. Okay, it's a monetary value with some other parameters, but to be honest, there are things like the NIST framework start talking about this, but I've never seen a definitive model that will actually take you to something at the end of the day. It's subjective. Some companies are very happy to take risks, some aren't. There's another level of subjectivity on this. So, for example, if say to use current events, if you were building a database on police brutality, then you're going to have some very, very interesting data fields in there. You can have ethnicity, gender, age, identity, and so on. Now, is that a risky database? I would say, from a privacy perspective, yes. From a usage perspective, no, because that's the necessary data you need to provide that service. On the other hand, if you're building a system that, I don't know, say a web-based calculator, if you were collecting user IDs from that, then that would be a risk because you're collecting things that are not related with the purpose of the system. So there's a number of levels to this. There's the risk that you take just by holding that data and the risk that you take from the necessity of having that data. So regrettably, I don't think there is a better mechanism than that. I would love to go and research that, alas, I never got around to that.
I think there's also an aspect of eye of the beholder. I mean, as a company, you can say, hey, I'm willing to take chances that I'm going to get a fine where I will lose my business, but hey, what's the chances of somebody finding that out? So that's, yeah, I think it's complex how to calculate it properly.
Yeah.
There's also a question about that, the information asymmetry between the user and the service provider. How could you address that?
Oh boy. You're not making it easy with these questions. Honestly, I have no idea. I mean, there's lots and lots of discussion about what a user should get back from a system. It depends, I guess, on your needs and values. It gets very, very philosophical here, I guess, or even, very personal. If you give all your data to Facebook, but you get something, so what are you getting back? I mean, all Facebook is really worried about is advertising revenue. And for that, they need to gather as much data from you as possible. They are, the information asymmetry there is basically they know everything about you, you don't. So I mean, if things were always random, if you were just seeing random adverts, we were clicking on things randomly, and it would be fine. I think that the problem comes is that when one party uses the information to influence the other party, then you see the asymmetry building up. There certainly is academic work on this. Helen Nissenbaum, Daniel Solov are the two people I'd go to for actually understanding this. Probably Helen Nissenbaum, certainly, but she has a much more philosophical perspective on this. But I think what it comes down to is how much leverage does one party get over another party. So if you're giving your information to Facebook or whoever, are Facebook using that information to influence you, and to what degree, in order to bolster themselves? So
Do you think? Oh, sorry.
yeah, kind of. Yeah.
Do you think regulation like the GDPR can have an influence in getting rid of this asymmetry?
An indirect influence, because I don't think the GDPR was. This was certainly in mind when the GDPR was written, but it was also. I think the GDPR was more written to give developers of systems. I think it really is an engineering document in some sense. It was written in such a way that it removed the restrictions on people as long as you take care. So what it should be doing is forcing people down the same route that aviation went down in the 1940s and the 1950s. And in fact, I'd say that's where the GDPR is at the moment. So I think it will get there. I think we might need another decade or two, and we would also need a large body of people who are sufficiently affected by privacy accidents. But in order to get there, we also need ways of investigating these accidents and keeping them in the public interest. You see, the problem is, while the GDPR gives us the tools, or at least sets us off down that path, we do not have the culture within privacy in order to get these things actually working. So, yeah, negative answer there.
No, I think I agree, and also because there's so much fluffiness in all these discussions, doesn't make it easier to get to that right mindset and culture, I think.
I'm seeing questions flash up here about regulations. That's
yeah. So the question: how regulations should be written in order to address a very changing technical world.
Actually, I don't think the technical world is changing that fast. So, the change doesn't worry me. Let's just say, I think the GDPR has got an awful lot of things right. It's got it right from a moral, ethical perspective, in that it's been written from the point of view that this piece of legislation must support both the citizen and the business, which gives you a lot of flexibility. The second thing about the GDPR, if you compare it to the original EU data protection legislation, which we've all forgotten the name of now, which was written from a point of view of you must be compliant, and now the GDPR has moved to you must not take risks. And I think that's a fundamental change for a piece of legislation. So from my point of view, that's how I think should go. We need to go down this risk-based approach, or this risk aversion approach. So I'm not a lawyer.
Yeah. So we have a follow-up question on that. So what do you say the GDPR has gotten wrong, or and I would say what's the most wrong part in the GDPR? In your opinion?
Lawyers were involved. No, well, okay. I think I'll come out and say I think the GDPR is a absolutely fantastic document. The way it's been written, on what it's trying to achieve. So fundamentally, there is nothing wrong in the GDPR. I think what we have wrong is the process by which this kind of legislation gets written. On the other hand, we had Working Party 29, who were actually actively soliciting input from engineers. I was actually part of the group who was soliciting, who was providing information to our WP29 representatives, and the statements about risk and risk aversion or risk avoidance you can trace back to me and probably a few other people as well. So I don't think the GDPR has got anything fundamentally wrong. It might be a little bit too conservative in some places, and it might be a little bit too weak in other places. So I think the biggest weakness is that we do not have the risk or the kind of safety critical culture in privacy at this moment. On the other hand, you have to start somewhere. So I think at this moment, the GDPR has done the best job it can or is doing. We'll just have to see how this actually goes over the next 5 to 10 years, to be honest, and what kind of changes end up in there. But I don't think the GDPR has got anything fundamentally wrong. If anything is going wrong, it's because the way we're interpreting parts of it.
And what about the whole consent part in the GDPR? I mean, looking at your experience, the challenges you had getting lawyers to understand engineers and vice versa, I think you have a similar thing between consumers and businesses. So the whole consent part is about businesses being transparent in what they do to consumers. But how successful can that be?
Unique consent. Period. And so I think the problem comes with how we present that consent to consumers. When we started trying to calculate or compute privacy policies, we actually saw the disconnect because privacy policies are not written by the engineers, they're written by the lawyers, and the lawyers do not have that extremely deep understanding of exactly what the system is doing. In fact, the terminology doesn't translate. I mean, we really are going through two different languages here, legalese and the engineer speak. And all we did was build a framework that allowed some form of translation, a Rosetta Stone, if you like. The problem I see with things at the moment are twofold. First of all, the way we are writing privacy policies is from a legal standpoint, and it's from a compliance standpoint. The second part is that privacy policies, or the way the consent is being presented to people, is very, very obtuse and obscure. So if you think that, for example, there are very few websites that will actually give you a sensible dialog box. You go to a website, you get dialog box up, select which cookies you want us to allow and things like this, and what you want your information to be used for. There is some very deliberate bad design of these. And the reason being is because you're trying to trick people into doing things. So we have this fundamental mix between the policies not being written about the systems that are actually being built, and then the way the consent is being presented to the user as being fundamentally dishonest. I don't know how you would tackle that, to be honest. There are a couple of sites. For example, there's a tech site called Slashdot, who basically ask you outright, do you agree with our privacy policy? If you say yes, they collect data. If you say no, they don't collect data, but they still allow you to use the full functionality of the site. So there are some people who get it right, and there are a lot of people who are deliberately getting it wrong.
Yeah. So we have another question, a bit more about the original contents of your presentation. So from your experience, what kind of people need to be collaborated within an organization to really put it forward, to really make what you presented work? Which kind of people do you really need?
Okay. Well, at its simplest, the privacy officers, the privacy lawyers, and the engineers actually building the systems. The fundamental cultural shift is that the privacy officers and the privacy people in general have to understand that we need to build these systems. Okay, they're going to be built whatever, it doesn't matter. If you try and prevent a system being built, the engineers will fight back and say, no, we're not going to talk to you anymore. And then things break down. So what you need to do is change your culture rather than get people together. Now, if you want to get this working, the best way to do this is to find a small team of engineers and actively go in and help them. Actually, and by actually going in and helping them really just go in and sit and watch what they're doing. And to, there has to be this no blame attitude and this no blame culture. One of the biggest problems that we saw in getting people together is, there's no trust between the lawyers and the engineers for a start. So you do need your privacy officers and your lawyers to have some kind of engineering training. Then it goes very, very well. To get this started off, you need a small team of people. So you need the lawyer who's also on that project team, and that lawyer actually has to sit down and possibly even write some code, or even just point at the screen and ask the engineer, what does that mean, and be willing to learn about that. The other thing that needs to be done is that the culture of dealing with the privacy requirements and so on, you can't say no to anything. You need to say, okay, this is how we can do it better, or the lawyer needs to phrase that in, could we do it this way, or what happens if we do it this way, so they better understand what the engineer is trying to do. The most difficult people are the managers or the requirements managers, because they like getting their fingers in it everywhere and changing requirements at a very, very rapid pace, just because they can. And that's where you get the difficulties. So it's not so much getting the lawyers and the engineers together. They'll quite happily work together because they end up with a common enemy of the manager who keeps trying to change everything and get involved. So that's to actually do this, you need to change the culture quite a bit and actually get these two groups talking to each other.
Thanks. So I have another question. I mean, a bit of a follow-up on the previous question. We already had somebody mentioning that the world is changing. Well, maybe not changing, but it's certainly speeding up. This whole DevOps movement is all about automating as much as possible. I think you did a great job at normalizing privacy, making things concrete. What do you see is the biggest challenge in automating this thing? What needs to be solved, which is really a fundamental problem at the moment that prevents this from automating properly?
Okay, we don't have the tools to do this. So the first stage in automating is actually having some tools that properly integrate with the software engineering process, and that is fundamentally incredibly difficult. I think it can be done. I've seen quite a lot of research on this. I mean, there was some things at the IWPE conferences over the years. What's been lacking for about 10 years, I started off in this area, I'd say 10 years, 15 years, is software engineering research that actually brings a number of areas together, such as privacy and so on, and trying to integrate into this. I can give you a very, very technical answer. So a lot of the stuff I've done here is based on description logics and type theory, which are two of the fundamental mathematical constructs behind programming. So I actually see this as being actually trivial to integrate with programming languages and so on. But the amount of tools that sit on top of that and the amount of structures and theory behind these tools is immense. We can build standalone tools very, very easily. I built a few tools to go and do this analysis with this, a few proof of concepts. But actually getting this working and people using these kinds of techniques, you need to have it built into your tool sets right from the beginning, and we're not there. We do not have the structures in our programming languages to do this. Or we do, but we do not have the, shall we say, the tools that can take advantage of those structures at this time. So there is so much fundamental software engineering work to do on this to get it working. But if somebody actually goes and builds a data flow modeling tool, Microsoft have something like the Stride tool. I think it's a little bit old now, which could be modified to do this. And this is where some of this came from actually. Then we could build tools to do this rather easily. I mean, I've built proof of concepts myself.
Yeah, you also see that in security as code and compliance as code tooling, they do also try tagging within the code to make it more clear and being able to pick up by tooling during build phases and stuff like that. But the problem I see is that it still all depends on humans actually adding the text. And if they don't want to, or forget it, or fill the right text, then your whole system breaks down.
I've actually seen some quite nice research on taking the data types used in languages like C, Python, Java, etc., and actually making privacy inferences out of that. And there are some very clever that, but they've all been at the research level, unfortunately.
Yeah. Okay.
Okay. Now I can actually see the chat.
Okay.
So, Finke Harkonnen has asked something. Thanks, Finke. When does a cyber incident trigger a GDPR breach report? Good question. No idea.
So I think that will be more a question for another meetup session. But
No,
there's a question from Anna.
Yeah. Let's have a look at this. My experience, change of mindset, yes. Okay. Ooh. What was the topic? You had the headbutting on your lawyer colleagues. Which way is the headbutting go? Is it me headbutting them or them headbutting me? I think they headbutted me often because they hated me because I come up with lots and lots of awkward questions for them. Both, thanks. Okay, so I'd say for the first couple of years, the headbutting went both ways because we just did not understand what each other was talking about. We had no common frame of reference. There were no lawyers with engineering experience and vice versa. So that was the first part. The second piece of headbutting we get was always to do with processes. Every time you want something, somebody would say, well, we need a new process to do this, which does not work in an agile field. The next big thing about headbutting was to change the terminology, to ban the terms PII and personal data. I mean, once we banned those two, then you'd still have somebody, but what about sensitive personal data? What makes it sensitive? Give me an answer to that. And, that was a real headbutting moment. You can't say sensitive personal data as a way of getting around my ban on personal data. So we a lot of the headbutting comes down to the fact that, there was this cultural difference between the lawyers and the engineers. From the engineers in general, they would always complain that they were prevented from doing things. The way privacy is always explained to engineers is, here are the set of rules that you must comply to in order not to do anything bad. And by the way, if anything bad does happen, it's the engineer's fault. Not the people who changed the requirement and tried to break the rules, etc., or the fact they were badly explained. But I think the really big headbutting moment for me came from the fact when I was trying to explain to the lawyers that you cannot blame the engineers for everything. If you can't explain, and if you're not willing to listen to them, they won't, they're just going to ignore you. So that was the most challenging thing I actually came across. Data location regulations, which you've mentioned there, that wasn't too much of a problem with us. I mean, that was actually easily dealt with when we did the requirements. So when we came up with the requirements aspects, when we talked about where the location of data, where data was being stored, we came up with a number of different types, whether on the local device, whether it was a local server. But when we start doing, okay, when it's out of our control, then we can actually be very, very precise and say, okay, which data center is it in? Is it a Nokia managed data center, or is it an externally managed data center? And once we had those set down, it was very, very easy to go to the engineers. So, for example, when I was working at Navtech and here, we moved everything out to the cloud, and then it was very, very clear which applications and which data could go to which data centers. So the location of the data was actually quite easy in the end, because it was actually very, very, it came really, it was very easily quantifiable, and it was easy to explain to both parties. So the lawyers basically said, this application or this data cannot leave Europe, That was easy for the engineers. We'll just spin up a data center in Germany or Holland or wherever.
Okay. Anybody has any more questions?
About your question before, Dave, there's a project called PDP4E. It's privacy data protection for engineers, where they're trying to, and make compliance together with privacy engineering in a kind of automatic way. Through tools. And well, I've asked already the team if they want to also speak here in one of the meetups and explain also what they are doing with that project. But it sounds really interesting. I will post the link here.
We need to find a solution somewhere in that direction, but I agree with Ian that it's probably going to take some time to get there, unfortunately.
Yep.
Yeah, that is a project still in development.
Excellent.
Okay, cool. Well, I also have no more questions. So thank you, Ian, for my part. I felt this was very interesting. I think you did a great job, and thanks for sharing that. And I really hope that this will be an inspiration for many people in our fields, and we can finally close the gap between lawyers and engineers for good.
Yeah, thank you, Ian. I've really enjoyed personally. Really to hear more real, practical, way of working in privacy engineering.
Yeah, even though I don't work in the field anymore, I'm back to sort of, should we say, much more lower level security research. If anybody wants to contact me, email. I think it's ian.oliver@nokia-bell. I'll send this out, and there's a clip as well. But yeah, feel free to contact me, no problem. And I'll go to Amazon and lower the price on the book.
No, don't lower it. Let's put it up.
Yeah.
Raise it.
Yeah.
Okay, so I think this will be the official end of the meetup. So everybody, thanks for attending. Keep an eye on the meetup group for the next meetup, which we will plan as soon as possible.
Yeah, we also have a Twitter page now.
Ah,
cool. I will put the link here. Otherwise, you need to be linked in Twitter in meetup all the time, and then maybe you are more in Twitter. So for the one of you that are in Twitter, there's also a link, and I'm gonna post here. Okay. And the recording, we will make it available. I'm not sure how yet. So
we will find a solution.
Yeah, we will find
the hard part.
Privacy friendly solution.
Exactly.
For all of us. Okay, thank you, everybody.
Thanks, everybody. Have a good night.
Bye.
Bye.